In this paper, we present ADAPT, a framework for authoring complex interactions between multiple embodied virtual characters using an extensible animation engine. Our platform incorporates character animation, decision-making, and navigation using modular interchangeable components to facilitate collaboration and experimentation. Animation is divided into discrete controllers called choreographers, which can share control of the body without being aware of one another. Rather than negotiating control over parts of the character's body, each choreographer is allocated its own copy of the character's skeleton. Choreographers manipulate their own private skeletons without interruption. Then, a central coordinator blends those skeletons to produce a final character pose. Some choreographers receive input skeletons, for which they compute an offset. For instance, the reaching choreographer and gaze tracker both base their position off of the movement of the locomotion and gesture animation choreographers. This system allows us to achieve simultaneous walking, gesturing, reaching, and gazing without explicitly designing our controllers to cooperate. Introducing a ragdoll choreographer produces plausible physical reactions to external forces. Fading out of the ragdoll's pose creates the illusion of recovery without requiring any springs or actuators on the character's joints. This physical reaction can be blended with any other choreographer. Our framework is highly extensible. We created a Kinect controller in a few hours and can blend it with the locomotion choreographer to allow a user to both walk and control the arms and legs of the character. This allows us to create some interesting interactions between users in our environment. Our framework provides path planning by means of a navigation mesh and predictive steering for collision avoidance. Because of ADAPT's modularity, alternatives such as navigation graphs can be utilized without drastically modifying either the behavior or animation components. Our system uses parameterized behavior trees for character decision-making, but can incorporate other paradigms using a simple interface. Here's an example behavior tree for a conversation between two characters. With parameterized trees, we can easily model interactions between actors as if they were limbs of the same entity. This tree represents a simple baseline and can be extended to incorporate more characters, more gestures, and better decision-making structures. Here we show more advanced behaviors for several characters in a short scene, taking advantage of ADAPT's animation, navigation, and behavior capabilities. This crowd displays 100 characters at interactive frame rates. The Adapt platform allows a user to easily add new character animation functionality and take advantage of that functionality at the behavior level. Because of this, our platform lays down a strong foundation for the next generation of narrative-driven simulations, with functional, purposeful characters in a rich virtual world.